Hi there, students. Welcome to geometry. I want to start by going over some vocabulary that we went over on our first day. This is essential vocabulary that is sort of the building blocks for us to move on. All right. Let's start with the simplest and smallest thing, a point. A point is a location. Okay. It's not actually real. There's no actual circle there. The circle is used as a representation of a location. A line is this one-dimensional thing that's essentially a billion trillion points in a row. It's these infinitely many points that goes on in either direction. Okay. A plane is what these things exist on. Geometry is all about planes because to put two-dimensional shapes anywhere, we got to have a space to do it. So a whiteboard is a plane, a blackboard is a plane, whatever piece of paper you're writing on right now, that's a two-dimensional plane that you're able to draw things like lines and then segments on. Segments are just like lines. It's just a part of a line. It doesn't go on forever. There's a very clear endpoint at either end. An array is this nice little combination where there's an endpoint and then it goes on and on and on forever in another direction. We're going to talk about postulates and axioms today. I use the word postulate a lot, but they kind of mean the same thing. These are essentially rules that we're not really going to prove. We are going to agree upon them because if we don't, then the world will collapse in on itself like a dying star. Right? The first one being the ruler postulate. Right? That if you have points on a line, okay, and we're giving them coordinates, we got to do a 1-to-1 ratio. So if this is 1, 2, 3, I can't then be like 4. Like that's insanity, right? If I gave you a ruler like that, you'd think I gave you a broken ruler. So it makes sense that we sort of say, yeah, well, we can't just stick with something like that. We need to establish some sort of rule. Otherwise, we're going to break some serious laws of physics. Okay. Next postulate we're going to talk about is the segment addition postulate. Basically, the idea I always bring up is like if you have a stick and you break the stick in half, the two pieces of the stick, when added together, must equal the original length of the stick. If it didn't, again, I don't know, logic would collapse in on itself. I don't know where we'd be living if that wasn't true. So these are why they're postulates. They're things that, yes, we're going to talk about and establish, but they kind of seem self-evident. So you might be thinking, do I have to write this down? And be like, well, yeah, but I understand if it seems overly simplistic. I want to talk about what it means to be congruent when we talk about segments. Okay, congruent is different from being equal. Okay, we can use congruent even if we don't know the exact measurement of something. We use equal when we actually know the measurement. So what I always say, right, is like if I have this segment here, and then I have another segment here, right? If I tell you that this is 5 inches, and this is 5 inches, then maybe I could go ahead and say, if we call this segment AB, that AB is equal to, we'll call this one CD. Right? They both have a measurement, 5 inches. Now, if I'm in a situation where I do not know the measurement, but I do give you what we call congruence symbols or markers. So if I put like 2 dashes in this one, 2 dashes in this one, right, and say, okay, these things are the same, all right, then I can still say that they are congruent. So I know that they do have the same measurement. I just don't know what that measurement is. I think the technical term for this, by the way, is an ampersand, but I call it a squiggle. So congruent is like an equal sign with a squiggle over it where it says, yes, I know that they are equal measurement. I just don't know what that measurement is. I'm going to use congruence a lot throughout this class. So I want to talk about these types of problems, which they do bother people a lot, so it's good to walk through them. This is how segment addition can pop up as problems on quizzes, okay? Here's the entire segment, and I give you little chunks, and it's your job to try and piece together the chunks to set up some type of equation. So I'm going to go over this one because I think it's a little harder than the other one because we got this overlap here, right? I think these problems can be visually confusing. I think one of the best things you can do is start marking it up as best you can. So like I would say, like, okay, 2x takes me all the way from W to U, and then U to T goes right here. So that, if I added those segments together, I would get the total segment. So if I added 2x plus x minus 1, I can say that that's equal to the entire segment, WT. Now let me change my color here and say, let's look at this. From V to t is x plus 9, and from v to w is 10. And those two pieces also add up to be the whole thing. So I could say 10 plus x plus 9 also equals wt, the entire segment. And if we remember from Algebra 1, well, if these things are both equal to the same thing, then I can set them equal to each other. So why don't I combine my terms here? 3x minus 1 should be equal to 19 plus x. And I'll kill two birds with one stone here if I can by getting rid of all the x's on this side and getting rid of the 1 on this side. So that I have 3x minus x is 2x, and 19 plus 1 is 20. Divide both sides by 2 to get x being equal to 10. And that's awesome, but if I look at my instructions, they want me to do a little bit more work and figure out what VT is, so I'm going to go ahead and plug that in there and get an answer of 19. So it's a short lesson, but that's our first lesson. And I'll be back soon to talk about it a little bit more.